Hello and welcome to today's webinar. It's on minimizing IoT project risks with future-proof IoT device management. My name is Jeremy Cowan and I'm co-founder of IoT Now, and it's my real pleasure to be your moderator today. Thank you so much for joining us around the world. I'm delighted to say that this webinar is brought to you with our partners AVSystem. Today, we're going to be learning how to start your IoT device management project off on the right foot. AVSystem will cover the fundamentals of IoT device management and will also dive deeper into common industry challenges regarding security and interoperability. So let me introduce you to our speakers. In order of appearance, they are Will Yan, President Americas at AVSystem. A really warm welcome to you, Will.
Thank you, Jeremy.
And Marcin Noj, Product Director for IoT at AVSystem. Very good to have you here, Marcin.
Thank you, Jeremy. Very good also from my side to be here.
Thank you both. Now, please don't forget, as usual, this webinar is being recorded. And from tomorrow, you can access the audio and slides at IoT-now.com and also from AVSystem's website. So later on, we'll be asking you for your thoughts. We'll have 3 quick polls and we'll all see the results immediately. And finally, after the presentations, I'll be putting your questions to our panel. I'm delighted to say we've already had some great questions in from the audience when they registered. So thank you, all of you. Please keep your questions coming. Start sending me your questions right now. Type them into the window on your screen, and we will discuss as many as we can in the time. Any that we don't get to, we will pass to AVSystem to come back to you later. And if you're having any technical issues with audio or slides, you can also use the question window and get help from our tech support team. Now, without further ado, let me hand over to Will.
Thank you, Jeremy. Thank you, everyone. Good day. Thank you for joining us today. It's our pleasure to share with you our experiences. And if we can simplify IoT into 3 layers, you got just like the word IoT, the T is the things. Things are the devices, sensors, actuators, controllers. So that's the device layer. Then you got the I, which is internet, which is interconnection, which is connectivity. So that's your either cellular IoT connectivity or your Wi-Fi, Bluetooth, your IoT connectivity. Stuck in the middle, the O, let's use that letter for one thing, standing for integration and application enablement. Today's topic, as Jeremy introduced, is focusing on the bottom layer, which is device management, issues related to device management to support your IoT services. Hello, thank you for joining us again. And so a few quick words about AVSystem. We are a software technology innovator. We provide specifically a IoT device management and data management platform. Our customers or partners are in the service provider space, global telecom operators, broadband service providers, fixed and mobile. Our customers also enterprises directly. That can be in any of the industrial verticals, aerospace, transportation, asset tracking, fleet management, and weather stations, and automotive industry, what have you. A third component of customers, partners working with us is what we call OEMs. These are the key players in the IoT ecosystem. They provide the chipsets, the modules, the sensors, the devices, and that enables the fundamentals of IoT services. We are vendor neutral, meaning we work with all manufacturers. We're access technology agnostic, meaning we work on, I just mentioned cellular IoT network like NB IoT, LTE-M, even satellite-based IoT networks. We are protocol agnostic, if you will, or multi-protocol support. We're going to get into more of the details of that in a second. So let's quickly review, do a level set. What is IoT? What are we talking about? Why we're single out device management today as a key topic. So IoT is all about digital transformation. That is the business imperative. That's what we are going after for. Digitize our business for efficiency, productivity, and operational longevity. It's about getting smart. We're connecting the dispersed assets, getting the data to glean insight to aid our decision making. Smart networks, smart device, smart machines, smart data, smart computing. At the end of the day, is to enable smart business. It's about connecting all of these things. It's also about remote control, remote management, which is really very relevant today because of the pandemic, right? So it put more urgency on the IoT projects. In our recent audience poll we conducted a couple of weeks ago, 50% of the audiences responded that their IoT project got put on steroid, accelerated growth, priority, higher attention from executives of the company because the urgency to connect things to remotely manage because of lack of a physical access or restriction of physical access, at least temporarily, before we are able to put this pandemic away. It's about automation, automating decisions, and perform autonomous computing. So what are the challenges now, you may ask? So security is a big one. The security of the devices, who can access, who cannot. The security of the data, who can access, who cannot. The security of the network. And how do we prevent denial of service attacks? Security is number one concern, as all of us know. Also, we're dealing with disjointed systems, disparate platforms, data from different places. Why do we need all of these data besides what we collect from the sensors? Because we want to put context to what's going on the device level to make smart decisions. We're dealing with torrent of data. It's going to be, now we're talking about thousands of devices. Actually need to be scaling up to millions of them, tracking your business, tracking the deployed assets. So scalability is a big issue. Comes with it has risks. How do you scale up? How do you design an IoT device management platform that can handle millions of devices for the future so they are not obsolete next year? So you need standards. Martin.
Thanks, Will. Thanks for this introduction into the topic. Let's now go a little bit deeper into this security concern. And as Will just said, it's probably the biggest source of concern at the moment. Leading security experts in the field say that current security awareness in IoT deployment is worse than it was in the 90s for the personal computer. Mikko Hipponen, the Chief Research Officer for F-Secure, in one of his speeches called Internet of Insecure Things last year, compared current IoT devices into IT asbestos of the future. He said, I'm quoting him, cheap, easy to manufacture, perfect in every way. You can mold it into any shape you want it. It's great for installation. It's great for fireproofing, but it's also lethal. The consequences of attacks on things can be far more severe than cyber attacks that we know from the past, because IoT enables us to affect the actual physical world. Previously, it was possible to make attacks against data or information. Now, it will be possible to make attacks against flesh, steel, or concrete. Stuxnet the famous malicious computer worm that made headlines 10 years ago, shows the scale of damages that an attack can make to an industrial infrastructure. One can imagine attacks against critical safety equipment, like smart smoke detectors, and impact it could have on human lives. Fortunately, in the last 2 years, we observed a raising awareness of the problem among important stakeholders. In 2018, FBI issued an announcement about making use of IoT devices for committing crime. And this year, we have also seen some work done by governments on specifying legal regulations that are required to be provided for IoT devices. What are the greatest sins in IoT security? The first one is no security by design principle. This stands in the stark contrast to development of mobile phones. Somehow we don't learn from our past mistakes. Personal computers were not developed with security features in mind because very few understood the importance of security at that time. Mobile devices, on the contrary, for them, the security design was the DNA of mobile security system design. This does not stand for IoT devices. IoT devices very often suffer from poor, buggy implementation of security features, like insecure credentials handling, usage of weak passwords, lack of proper communication protection, improper handling of personal and sensitive data. The second serious mistake comes from not thinking through how device should be operated in the field. Consequently, this leads to poor firmware or software update mechanism, very often ending up in using an old and unpatched operating systems for the solutions in the field. Will?
Yes, so we talk about the security, the importance of a security. We talk about the data, torrent of the data. So the goal is connecting all these devices to collect the data and get insight, make decisions. This needs to be processed, and you need a platform to be able to handle that amount of data. You need a platform be able to merge the contextual data with what you collect from the sensors and actuators. You need to consider the limitation of the cloud and where you want to do the computation, or send it over to the cloud, or compute at the network edge. So we also talk about the challenge of disjointed systems, dispersed data. It's the same idea. And each use case is different from what you collect, how you process, what to report, and what to act on. It's not a one-size-fits-all kind of approach. It really depends on your use case. For example, in the manufacturing shop floor, your sensors attached to the machineries is different from a transportation company tracking an intermodal transportation piece of a container goods on the ship, in the truck, on the highway, in the warehouse, so on and so forth. So it's all about how to make relevant systems work to yield relevant data insight. To that point, of the few risks in IoT device management, here comes our first question. We want to ask you how your company is dealing with this. Jeremy.
Will, thank you very much. Let's go to the first poll then. And the first poll is this. It's asking what's at risk with your organization's IoT project or digital transformation journey? Is it the lack of executive leadership and sponsorship? Is it a lack of relevant, up-to-date IoT technology? Is it the lack of technology standards? Is it having a hard time justifying the business case or the return on investment or savings or new revenue streams? Or is it something else? So quickly, what's at risk with your organization's IoT project or digital transformation journey? A lack of executive leadership, lack of relevant up-to-date IoT technology skills, lack of technology standards, or having a hard time justifying the business case, or something else. And we can see the results coming through here. The preponderance there, the 48%, is about where it's settling, around having a hard time justifying the business case. Anyway,
very interesting, Jeremy. It's like sounds like nobody want to point fingers at their boss. 0%.
Yeah, nobody's going to say that, or are they? This is anonymous, so they can say what they like.
Oh, that's right. It's critically important for us to point out. It's confidential. Your response
totally
is
confidential.
only reported.
We can't see who's replied in what way, so you can always say what you like with IoT now. Anyway, thank you, Will. Back to Marcin.
In IoT, we observe, a multitude of available device communication protocols, and the two most popular ones are MQTT and the lightweight machine-to-machine standard that we at AVSystem are strongly advocating for. But we should also mention about other existing solutions. We see HTTP being used by some vendors. We see a close cousin of MQTT called AMQP. There's also these two protocols work based on the public subscribe communication paradigm. We see also a very popular protocol called XMPP that is very widely used in the real-time communication system. We are also seeing the older brother of lightweight, OMADM. It's been almost 20 years in the field, and also CoAP, which is optimized version of HTTP protocol that can be used for the constrained network and resource constrained devices. What is a unique feature about lightweight machine-to-machine is that it is offering a well-defined data model that I'm going to explain right now. So let's take a deeper look at lightweight machine-to-machine. The important thing is that it has been created with the purpose of operating on constrained devices and in challenged networks. It recommends using UDP as a transport protocol, as it doesn't require a connection handshake overhead, which can be problematic in challenged environments. Since not all networks forward UDP traffic, there's also support for TCP. There's also support for transport over SMSs and non-IP networks. CoAP, the other protocol that I mentioned on the previous slide, is the default application layer protocol, and payload of CoAP is filled with lightweight specific content. Since version 1.2 of lightweight machine-to-machine, there will be additional support for MQTT and HTTP in addition to CoAP. So here it is very important for us to understand this difference between protocols that we described on the previous slide: MQTT, HTTP, CoAP, and lightweight machine-to-machine. Very often, people try to compare lightweight machine-to-machine with MQTT. And this is not a fair comparison, because lightweight machine is going one level up. It defines the model of the data that is going to be sent to the devices, which makes it challenging to work in the beginning. But it also provides lots of ready-made functionality that can be used later for you. On the other hand, with protocols like MQTT, CoAP, or HTTP, it's your job to still develop the format of the application messages. So you may shorten or short circuit a little bit of your time in the beginning by providing your own custom format of the application protocol. But however, in the long run, you may end up in problems related to interoperability or of the things that you did not think through, whereas the similar problems have been already encountered by the designers of lightweight machine-to-machine protocol. So coming back to the more details about lightweight, there are 4 interfaces defined for bootstrapping of device, for registration, management of devices and service enablement, and finally for the information report. These interfaces define all operations needed to provide the whole device lifecycle management functionality, all through information and through information reporting interface. It also provides data monitoring capability. As I already mentioned, this crucial feature of lightweight machine-to-machine is a well-defined data model that describes device state as a set of objects and resources that can be read, written, or executed depending on their nature. There are various payload formats available: TLV, SNML with JSON or CBOR. There's OPAC, there's plain text. And these various payload formats can be used according to particular device operation requirements. Finally, security of communication is provided by DTLS protocol, which requires successful authentication of both client and server for successful communication. This is a very important aspect, that it forces the server to actually check the identity of the device. And what we see recently is that popularity of the lightweight machine-to-machine is growing in recent years, and all of big players among the chipset vendors start to provide support for it.
All right, so thank you for the detail, Marcin. That's really detailed explanation what is lightweight M2M, and also a little bit of a comparison with what's going on in the marketplace. So as Marcin mentioned, lightweight M2M is a device management protocol of technology initiated by Open Mobile Alliance, OMAR SpecWorks. So you got a major support from enterprises, telecom carriers, and lots of OEMs in the IoT ecosystem. So how it's being applied is on the device level, the chipset supports the protocol. The device, the modules, the sensors themselves, being able to communicate via this technology standard. So you can pull data, control it, monitor, diagnose, and report. So there's a wide support of OMAR lightweight M2M technology, a wide support of a IoT ecosystem. And I'm going to go into the next slide. So we've been talking about device management and device management risks, security, scalability, and future-proof. What is device management fundamentals? What are the things a device management platform is expected to do? Number one, we need to onboard the device, right? We need to authenticate a device, and we provision the device, perform remote control, remote configuration of the device itself, and we do monitoring, continuous monitoring diagnostics. We perform firmware updates, security patches. And security is such an important topic in this IoT services. We do troubleshooting. These are table stakes in the basic device management platform. So Marcin will take us through some of the life cycle issues in terms of device management.
Yes, let's now have a quick look at the device lifecycle management, also from the responsibility party point of view. There are four main phases of the life cycle. In the pre-commissioning phase, the OEM builds and configures the device for the initial deployment, and this is the sole responsibility of the OEM to do it properly. After that, the device is commissioned to operation, and responsibility for this device is transferred to the operation team. Then the next phase is the management, which constitutes the core part of the device management. Once the device is no longer needed, again, the operation team executes the commissioning. So we see that there are two stakeholders in this whole device lifecycle management: OEMs in the initial part, and after this, the responsibility is transferred to the operations team. I'd like to illustrate the process that each OEM takes in order to build a device and keep adding new functionality for it. This is an example of how device management can be used for it. When you start thinking about building a new device, you start with doing feasibility study, that you want to understand what are the functional requirements, what are your constraints, and you ended up by selecting a hardware and starting to develop software that you are going to put onto your device. After you are reasonably happy, you start the whole never-ending cycle of testing device functionality, checking its interoperability. Then you provide some default credentials for the so-called factory credentials, and the device is ready to deploy. But once the device is ready to deploy, there's always upcoming things. There is a request to provide new functionality. There is a bug that was discovered. There has been discovered a vulnerability. So this all requires OEM to take proper actions. Some of these are corrective actions, sometimes are development actions. They work on the new functionality, work on the right new code, and then there is a question: how do you test this code? So you come back in this loop to the same process. You test functionality, interoperability. Maybe you don't provide the factory credentials. Again, this might be an omitted step, but then you are ready to update the device to put it in the field. We call it continuous testing process and conformance testing. And this is one of the device management applications. Similarly, we can formulate a similar process that is happening for the operations. Once the device is provisioned and configured to be deployed, the operation team starts to collect telemetry and device data. They look at this data and then they see there are some things that are not working as expected. So they go into this diagnose phase and they fix problem. And then again, after the problem is fixed, they will need to redeploy the device again by providing some software. So we are here in the process of continuous monitoring and continuous improvement, never-ending process. And now there is time for the second polling question. So I give my control to Jeremy.
Thank you very much, Marcin. Let's have a look at the second poll question. What's your organization's most pressing IoT device management challenge? Is it selecting a device management platform? Is it finding an in-house developing an in-house device management platform? Is it making the current device management platform work effectively? Is it that we can't be bothered by it and expect device manufacturers to provide it with their devices, or something else? So which of these is your most pressing IoT device management challenge? Selecting a device management platform, developing an in-house platform, making the current device management platform work more effectively, or expecting a device manufacturer to provide it, or something else? And Will, there seems to be a neck and neck for the first and the third, selecting a device management platform or making the existing device management platform work effectively. Is there anything you want to add to this?
Very interesting response here, and it shows that you came to the right place. Either you answered one or the third. So this is the right webinar for you, and either you're in the process of selecting a platform or you want to make your existing one work better. So that's what we're talking about here. So we can go offline after this webinar, get a further conversation with you based on our experience.
Excellent. Thank you, Will. And back to Marcin.
Thank you. Thank you for this poll. Now let's get back to security. We talked a lot about it, and let's briefly discuss the good practices. The first thing is that communication between a device and application server must be over secure channel. We mentioned that credentials management is a very often encountered problem. This means that credentials must be properly secured on the device. For this, we recommend storing them using some trust store, or even better in a hardware security models if this is available on the device. We also recommend using device certificates for device provisioning, and these certificates can be provided by the public key infrastructure system. In such a use case, the preferred option is to generate a public private key pair on a device and send the public key via the IoT application server to PKI that is supposed to generate certificate out of it. This way, the private key never leaves the device and remains stored securely. The second important problem that we touched here was about scalability. We have to assume that there are going to be millions of devices connected, and at some point, communication with the cloud will become a bottleneck. So the way to go, as Will already mentioned earlier, is deployment of edge platforms. And according to Google, more than 90% of data generated by devices provide very little information and can be handled by a simple logic that can be deployed at edge. In such an architecture, edge plays the role of platform as a service, where arbitrary logic is executed and it is managed from the cloud application. The logic of edge applications support device operation. It may involve data filtering, data aggregation, also time-critical decisions where there is not enough time budget to send data for decision to the cloud, but the edge device will provide an answer to this, and also artificial intelligence mode. Now again, time for the final polling questions. Back to Jeremy.
Thanks very much,
I think
Marcin. We have the final poll question here, and it is this: what IoT device management or IoT data transfer technology or protocol is most relevant to your organization's IoT initiative? Is it MQTT, lightweight M2M, TR69/369, AMQP, or something else, or you're not sure? Is it MQTT, LWMT M2M, TR69/369, or is it AMQP, or something else, or you're not quite sure? And that is quite evenly split. Will, there seems to be a slight lead for lightweight M2M. Is that what you were expecting?
Kind of, yeah. It's no surprises there. And what we're seeing is across the board, various technologies being adopted, used in place today. And we are seeing very encouraged to see that lightweight M2M by Omar SpecWorks. It is designed for managing constrained devices over constrained networks. Examples of that is a sensor, low battery power, low memory, and low flash, all of that, and millions of them out there, and going to transmit over narrowband IoT. It needs to be lightweight. So we see the emergence, influential position that lightweight M2M is shaping up to be. MQTT has been around for a long time, as Marcin is explaining to us. And TR69 and TR369. TR69 is also Omar's standard. Traditionally, it's widely deployed in the past. It's more of a legacy. And so I'm not surprised there are still some people not quite familiar with a specific technology. You could be the business owner, which is an IoT service at the end of the day. It's not about technology, right, Jeremy and Marcin? It's not about technology. It's about a business case. So you came to the right place if you are not familiar with these technologies, because at the end of the day is really driving to a direction to make sure to service your application needs, your use case needs. So I'm not surprised at all, but I'm also encouraged. A fair amount, 33%, a third of the audience answered the question, is somewhat at least familiar with lightweight M2M. And I'm very encouraged, and I'm sure Omar SpecWorks will be very happy to hear that as well.
Likewise. Well, look, that's a really fascinating response from the audience, and thank you for your thoughts on that, Will. I'm going to close the poll now and go back to you, Will.
Oh, okay. I think now we're talking about a few folks already started asking questions. I'm glad you're engaged with us. Very good. So the key question, and I'm sharing this quick glance of the questions is, where do I start? How do I start? I know lightweight M2M. I know you guys are pretty good with this stuff, lightweight M2M. And how do I start? If my device is not ready to support lightweight M2M, what do I do? So help is on the way. Omar SpecWorks. If you go to GitHub website, they got open source tools available. One of these tools is called ANJAY SDK. It happens to be from us, no secret, from AVSystem. We provide an open source tool to enable you to get your device ready, be able to communicate northbound to the server management platform. So you can use that ANJAY, and there are other choices too. We happen to be to know that major enterprises and telecom operators are already adopting ANJAY to do the work. So there are two flavors we can do. Martin can get into more detail, but I'm going to highlight two things. If you choose, you have the development capability. Your company can just use the SDK to write your code, do the firmware, and your device are ready to go. Or you have a limited resources, limited knowledge. You can hire a company for support like us, from us, to build the firmware, develop the firmware for you, and support it. And the goal is the same. How do we quickly deploy the devices to support IoT services on a massive scale? That goal, either of this mode support the same goal. Martin, anything you want to elaborate a little further on ANJAY?
Right. So one of the common things that we kept hearing in the recent months was that there is not much of lightweight machine-to-machine ecosystem. It's just difficult to start with. So in the last couple of months, we have dedicated quite a significant amount of time to providing more of tooling for quick and rapid development of lightweight machine-to-machine applications. We provided a network shell for rapid client testing, which allows you to just verify as if you were connected to the server if the device is responding properly to your commands. We have also launched Try ANJAY platform, where you can just have a open and free access to our server for trying to execute operations remotely using lightweight machine-to-machine protocol. And finally, we have started publishing ready-made integrations for the popular development boards. We have covered STM32 boards. We start now working for providing ready-made integrations for the Nordic semiconductor boards, and then we will keep on adding more of these developer boards, always with the spirit of reducing time to market, helping you bootstrap your lightweight machine-to-machine application. One very interesting thing that we have developed and published recently was this rapid prototyping application based on ANJAY that you can execute on your Linux machine as if you were writing a simple Python client. We are highly encouraging you to go to our GitHub page and download it. You can basically build your lightweight machine-to-machine application in a couple of minutes just using it. Then on the server side, we mentioned a lot about testing and interoperability, and one of the key features that we are offering is the testing framework with a set of predefined tests, testing conformance of your device with the lightweight machine-to-machine protocol, testing if service is behaving if the service on your device is behaving as it is supposed to behave, some performance testing of your stability, security features, and connectivity. And on the second aspect of the responsibility, we talked about a tool for the operations. Our Coyote platform provides functionality for executing remote configuration operations, pod management, monitoring, FOTA, and it also provides an easy way to attach application enablement platform, so that you can manage your devices from the third-party systems and execute proper operations based on your business needs in your application.
That's really good. That's really good detail. So if I go back to this slide, what Martin mentioned in terms of the predefined tests, in our experience deploying IoT services around the world with major enterprises or telecom carriers, we see a step one really important is interop testing for device onboarding, isn't it, Martin? So we see this all the time. So people are asking us for automated platform to automate these tests at the protocol level, at the service level, performance, scalability, and all of these. So there are companies, enterprises or carriers, they have a multiple different kind of tools. The problem occurs when they start doing interop, because you're going to end up with more than one brand of sensors, right? You're going to end up with supporting the sensors has multiple, not just one chipset unit either. So different modules, all of that stuff. So you need an automated platform, and Coyote happens to be the tool, or ANJAY happens to be the tool that can help you to do that. And so that's a step number one. Get device onboarding. We see that a major challenge before we even get take off for scalability, right, Martin?
Yes, definitely. I think we are also now observing this quite positive feedback from our customers that started using it and saying, that this massively reduces their time to market for providing devices just for the initial deployment.
Right. So we talked about today the digital transformation. What is IoT? What is the device management in IoT? What are the risks associated with it? What are the popular technologies going to be able to be employed to support all of these? And Martin took us really down very deep level technically, explaining the protocol, explaining the functionality, including some screenshots. I think, Jeremy, at this point, we're about another 15 minutes left in the webinar, and let's open the floor up for audience questions.
I think that's a great idea, Will. We've got so many questions and some really good ones. Let's go to the first that I would like to put to you. This is from Omar Monroy, who says we need to integrate wireless sensors or actuators to our current hardware platform, comprised of Modbus capable power meters and heating, ventilation, air conditioning controllers. How can this be done? From this aspect, could I come to you, Martin?
Right. So thank you for the question. Modbus is an industrial type of protocol that's fairly popularly used within industrial devices and so on, like power meters. It is not lightweight machine to machine, so there is a need for if Omar, you are interested in integrating your solution with lightweight machine to machine, then there is a need for translation of Modbus messages into lightweight machine to machine messages. So this can be achieved by using a gateway that is going to become standard for the 1.2 version of lightweight machine to machine.
The next question, thank you, Martin. The next question that I'd like to put out there is more of a market one. So maybe one for you, Will. How do you see the evolution from SIM-based connectivity end-to-end towards IoT, that is device and data management, for mobile network operators over the next 5 years?
I think the cellular-based IoT network is going to play a major role in IoT services, and there's no doubt. Parallel to, that's why you're seeing the adoption, the take-up rate for NB-IoT. It's more of a guaranteed quality of a service so to speak, than a non-regulated band. So, but in parallel, you also see this. We hear a lot more nowadays about this 5G, right? And 5G and the private IoT networks. So enterprise is going to go out there to purchase bandwidth on their own and their spectrums and launch their own private IoT networks. But I still see really good prospects for mobile operators to be very relevant in this IoT services, especially for managed service, right? Across the globe, not only limited to one territory. The mobile operators, the SIM has global roaming capability or roaming partnerships. They're stitching together and give you that scale. I think from my perspective, that's going to be very important for multinational operations. For example, in one of our deployment supporting a transportation company, and the company is a European company. The container ship left in Rotterdam, going to the Mediterranean and go to the Pacific, and all the way come to North America. So all of these process is global in nature, and that's what IoT is also a key aspect of it. Is a global nature of operation, being able to track and trace, to collect telemetry data, execute decision, no matter where it is in the process.
Fair enough. Can I stay with you for this one, Will? Marcin may want to comment as well. The questioner asks, can we use Coyote over either LoRaWAN wireless M-bus, or is it dedicated to GSMA 3 GPP protocols?
Well, very good question, Victor. And absolutely. And Coyote is lightweight M2M protocol based. It supports LoRaWAN. Definitely, it does support. Maybe Marcin, if you are open to explain a little further the technical details. But you know, we have the, you know, at the moment is a lot of our deployment is on the NB-IoT side and Wi-Fi and Bluetooth low energy networks, of course. But we have a couple of early stage in the LoRaWAN space.
Marcin, did you want to add anything on that?
Well, basically, you know, Coyote is in the most basic solution. The Coyote is the, you know, IP access platform. So whatever you can connect to the IP network, you can use Coyote with it. We are also providing some gateways for non-IP data access as well. So we are not limited just to IP networks. However, this is not the basic functionality of the platform. And finally, I also wanted, you know, to mention about this non-IP environment is that there are also existing technology solutions for this that you can also run IP over the non-IP layer. For example, you can run IP over Bluetooth, and then this way you can easily run lightweight machine-to-machine using the Bluetooth networks.
Thank you, Marcin. Still 7 or 8 minutes left, and we have good questions coming in all the time. This one is, do you think LoRaWAN or NB-IoT are a solution for the large-scale IoT devices? If you do, what are the challenges? Will, what's your view on that?
This is an interesting one. At least for large scale, yes, the primary the goal is supporting large scale IoT services. You know, not a huge number of devices. I think where the question comes from is this: the reality today, most of IoT projects are still in the early stage, in the POC mode, and if you will. So people haven't really started thought out the future when millions of sensors can be connected. So I think it's still the issue is still the which network to choose really depends on. It's not because the technology one is better over the other. I think I said this before. It's our experience tells us it's more driven by use case and what is driving. For example, when we do things in Brazil, agricultural IoT is a huge space, getting a lot of attention, a lot of investments. Tracking the crop field, temperature, pressure, moisture level, insect activities. That use case is very different from the example I mentioned, the transportation, going through 7 seas of the world, if you will. So I think it's more of a use case driven over technology in here.
Thank you, Will. Here's kind of a market question with a technical aspect. Will, I'll come to you with this one first, if I may. This was kind of brushed over, touched on in our polls. How many device vendors already use lightweight M2M? And is lightweight M2M taking up fast? What's your thoughts on that?
Very good question. So I'll answer this as 3 things. I'll give you the data, right? The best place you can go may not be very current because there are more vendors coming into the space working with Omar SpecWorks. But if you Google Omar SpecWorks lightweight M2M, they do give a list of some of the vendors who are participating and are supporting it and part of that ecosystem. That's one number you can go. Second number I'll give you is our proprietary data, who we are working with. We're working with no less than 40. That's conservatively, based on what I'm aware. And the vendors, the chipset vendors, the module providers, and no less than 40. We're doing testing work, interop work that we're working with. And that's 40. And every day there's a new one. And we got a lot of inquiries. It's not kind of a bragging, but we invested early, or lightweight M2M, about around for 7 years. We're one of the companies invested early. We voted ourselves to the top for lightweight M2M based device management in IoT. And therefore, whenever people Google lightweight M2M, they come to us. They at least pick our brains, so which is good. We don't mind to share our experience. So every day we got a new device manufacturer asking us how to support lightweight M2M, what tools are available, and what are the issues they need to be aware, what resource are their developers, skill, embedded engineers, and we got inquiries like that. So I missed the second part of that question. So how many was the first one? So what was the second part? Can you roll back or?
I can't go back on that, but it was really just to understand how widespread it is.
Yeah, so we're seeing after 7 years, it is still emerging, but this is more of a plug for Omar SpecWorks that Martin mentioned. Current release a couple weeks ago is 1.2, and then on the roadmap going forward, they want to make this more enterprise friendly, more cloud friendly. And there may be a hidden question somewhere. Somebody's going to ask, why is the major guys, Google, the Azure guys, not coming out strong? But they are in the ecosystem picture. If you go to Omar SpecWorks, and at the moment, specialty shops like AVSystem, we are leading the market.
Fair enough.
We got a new one.
Well, there's another question. Not unrelated, somebody who would like to ask about this is lightweight M2M restricted to IP networks? Clearly, they want to pick your brains as well. I thought the data models asked the questioner are an encoding standard, not a transport protocol. Marcin, would you want to comment on that?
Sure. So first answer to this is that lightweight M2M is not restricted just to IP networks. There are these bindings for non-IP data delivery as well. Regarding the second question, the data models is the big advantage of lightweight machine-to-machine. It just lets the user model the state of the data in a well-organized, well-formed manner that is also accepted by the community. This means that it's not only you that thought about it, but there are also other eyes looking at it and providing feedback. Did you think about this corner case? Did you think about other corner case? And this data model can be encoded in multiple formats based on the particular requirement of the network. It can be encoded as a TLV, which is type length value type of format. It can be encoded as JSON or as CBOR or whatever other format. I think what is important here to understand is that encoding is just about how do you put the bits on the wire or send them in the air. But the actual value is in this abstract concept of the data model, which tries to visualize and describe state of the device, and this is above the encoding standard. There are multiple encoding standards so that you can choose whatever is the most optimal for your particular solution.
Fair enough. Marcin, thank you. There's time just for one more question. I'm going to bring this to you, Will. How do you scale your idea or product across various networks with different operating systems, both regionally and globally? Broad question, but a good one.
It's a good one, but we need another hour to do this one. Maybe that's a perfect tee up for the next webinar. Quickly, and I think, like I said, my first advice is figure out what's your business objective. Figure out what is your use case. That always dictates what technology you're going to adopt, what network you're going to choose. So the second one is you got to analyze economics. I realized from the first poll that overwhelmingly, 50% are saying that justify the business case is a major challenge. So in any organization, if you are a change maker, if you are a transformational leader, you got to think about how to deliver value in the shortest amount of time to get executive attention, support, and organizational synergy to make this work. Otherwise, it's going to be killed in the infancy. Okay, are we done? Or slides going backward now?
I think we have to wrap it there. That's a great shame because there are more questions coming all the time. And as you saw, they are really good. And you guys have been very sporting, taking all questions from all comers. Thank you so much. Thank you. I'm afraid, as I say, we are out of time. There's nothing, we can't beat the clock. To everyone watching, please don't forget to bookmark our site at IoT-now.com. And there you'll find the latest news, blogs, and interviews. And most importantly, from tomorrow, you can stream this webinar at the site too. It will also become available at AVSystem's website as well. So it just remains for me to say a big thank you to our speakers. Will, Jan, many thanks for your time and your expertise, Will.
Well, thank you. Thank you, Marcin. Thank you, Jeremy. I think we had fun, and look forward to do this next time of a topic of your choice.
It's been great. Let's do it again. And my thanks also to you, Marcin. It's been really great to have you here.
Thank you, Jeremy. Thank you, audience, for your time. Thanks for the great questions. Thanks to
follow up with us is AVSystem.com. AVSystem, no S, AVSystem.com. We'll see you there. Thank you.
Thank you. Most of all, ladies and gentlemen, I want to thank you for joining us around the world with AVSystem. And from here, from everyone at IoT, bye for now.
Bye-bye.